Hey everyone, good morning all of you. Yeah, I think we are live. Yes. So, how are you all? And how's your journey? How's your preparation for NEET 2026 going on here? Good morning, good morning. Yeah, so, I hope you have enjoyed the Sunday break in between. Uh, Talking about these sessions, before Sunday, we have discussed two important things in our physics track one. That is the track of mechanics, which we are discussing, in which we have started dealing with the motion in a straight line, one of the topics with which students start, but in which students keep feeling, that there is a doubt even till the end of the preparation. So today also I have come in front of you with one of the topics in which most of the aspirants are having doubts. That is graphs, topic of graphs. You know what? I strongly believe that graph topics is a very easy and interesting topic for the students who are preparing physics for engineering exams. The reason is because they have mathematics as a subject with them. So definitely after learning the mathematical skills, after learning the trajectories, different equations, different shapes, conic sections, as well as the use of calculus, it's very easy to deal with any type of graphs, to study any graph as well as to draw any graph. All right. But for us as medical aspirants, majority of us, I would say only few of us, 5 to 10%, or maybe less than that, will have coincidentally, they would have maths along with the physics, chemistry, and biology. But majority of us are not having mathematics as an additional subject, and hence after understanding the limitation of all the medical aspirants, our today's session, today I have come up with a session in which we will try to learn all the fundamentals of the graphs, all the mathematical tools, which will definitely make you capable for two things. Number one, understanding and reading, analyzing any type of graphs. Number two, drawing any type of graph for any given situation. All right. So can we start now? Yeah. Good morning. Good morning, all of you. Slowly, our remaining friends also today will come. I can clearly see that this Sunday break was actually a break for everyone. Chalo, hopefully you have enjoyed that. Let's continue our session now. So today's discussion is all about graphs, but kinematics graphs. But last time also, when I met you, we studied good fundamental things, average value, instantaneous values, and I told you that right now we are studying these topics, emphasizing much on kinematics. But whatever you are learning in these sessions is going to be very, very beneficial for other topics and chapters also. All right. Similarly, we are talking about the graphs, emphasizing especially on kinematics. But there will be no chapter, there will be almost no unit in your NEET syllabus in which the graphical problems could not be found. All right. So almost in every chapter, I would say every chapter, every topic, you will have the graphical part involved. And after today's session, no one should be feeling any kind of discomfort with the graph. Okay, if the graphical problems are coming in the exam, we should be very happy that now to we are going to hit for the +4 marks. All right. So but in order to understand the graphs in a better way, I must have to take you towards the mathematical fundamentals. So let us start. Okay. For a while in between, you may feel that there is some more essence of mathematics getting involved. But trust me, once you attend the session completely, you will realize that whatever you have understood is very much useful. And I will also tell you my technique of solving motion numericals, solving kinematics numericals by graphical approach. What did I say just now? I said that examiner will give you a question and examiner will not specifically tell you in the exam that I want you to solve this question by equations, or solve this question by graphs, or solve this question by logic. So suppose it's a numerical, I'll show you today that there will be few numerical problems. One way is the conventional way, doing them numerically, but those methods for the NEET exam are going to be exhaustive methods, time consuming methods. You'll also get tired. But the logical approach and the graphical approach many times gives you a clear, a clear solution and a very compact solution for those crucial problems. All right. So first of all, let us try to understand the fundamental of the graphs. Then we will try to understand the types of graphs one by one. Then we will talk about each and every graph, and then we will see the problems, graphical problems, numerical problems, which can be easily solved on the graphical basis. Okay. Yeah. Chaliye. So we are starting now. So first of all, I would like to introduce the general types of graphs in motion. Like in kinematics unit, what type of general graphs we have to discuss. So first of all, I'm starting with the common graphs. So if I talk about the parameters of motion, like in equation of kinematics, or while understanding or analyzing the motion of a particular body, how many parameters you look for? You look for x, position vector, displacement, distance, all these things will be related to x. I'm not saying that x will be position also, displacement also, and distance also. No, I'm saying everything will be related to x. Okay, x can be treated as a position here. Okay, position. And let me write it as position vector. So are the displacement vector and position vector same, sir? No, they are not same. I'll tell you what it is. This is v vector, velocity vector. This is a vector, acceleration vector, and this is t, time. So out of these four parameters, I want you to understand that time is the only parameter that its negative meaning will not make sense for us. Its negative value will not make sense for us. It will not be meaningful. But position vector, velocity vector, and acceleration vector, since these are vector quantities, their negative sign will only contribute in the direction. All right. And what about the displacement and distance, sir? So displacement is s vector. Displacement is s vector, and that is basically equal to change in position vector. Change in position vector means x final vector minus x initial vector. Okay, final position vector minus initial position vector. So obviously these are different, right? Similarly, if I talk about the distance, so distance d is equal to total path length. So while talking about any numerical problem or a graphical problem even, be very, very clear about what is distance, what is displacement, and what is position vector. So in order to understand the different types of graphs, we are focusing on the parameters of motion, where the three are the vector parameters and one is the scalar parameter. So if I try to, if I talk to you, if I ask you in fact that in order to draw any graph, how many parameters you want to relate? So obviously the answer is two. One is x-axis parameter and one is y-axis parameter. Means the physical quantity or parameter, one is plotted on the x-axis and one is plotted on the y-axis. So out of these four, if I keep on selecting the combination of 2 and 2, any two, right? So how many combinations will be there? See, x can be related to t, vt, at, then vx graph, ax graph, and av graph. Once again, xt graph, vt graph, at graph. Let me write it for you. These are the common graphs. The common graphs are, number one, first common graph is position time graph, xt graph. Second is vt graph. Third is at graph, acceleration time graph. These are the common graphs. We all are familiar with, right? We keep on looking at and we keep on solving a lot of problems based on these. But if I talk about these graphs, which are rare but important, and these are not very rare for the JEE or other type of exams or Olympiad exams. These are also common, but for NEET these are rare. But looking at the pattern of NEET 2025 examination paper, we must not be ignoring them. We are not in a situation to take such a big risk. So we have to talk about the fundamental approach to deal with these rare but important type of graphs also. Those are, what are those three graphs? The remaining three combination: Vx curve, Ax curve, and Av curve. Vx curve, Ax curve, or Av curve means velocity position graph, acceleration position graph, and acceleration velocity graph. All right. So these are overall the 6 graphs whose fundamentals we are going to deal today. But whatever fundamentals or whatever the approach of analyzing the graphs we are going to discuss today for these 6 graphs is also going to be applicable for almost each and every topic and chapter of physics. All right. So any doubts still here? I hope that's okay. Now let me take you a bit ahead. Now we are talking about the use of calculus in graphs. If you want, you can keep taking the screenshots, although the notes will be also attached in the description of the live session one day later. Means if we are having the session today, you can download those notes tomorrow from the description. All right. Meanwhile, if you want, you can take the screenshot. No doubts? All right. Now we will talk about use of calculus in graphs. Use of calculus in graphs. So basically for any graph, what you need to focus on is here. I'm just mentioning it for you so that you will be mentally prepared. What are the things we need to emphasize on for any graph? For any graph, phase 1, we are trying to understand the use of calculus. Use of calculus means that will be differentiation, that is dy by dx. Differentiation gives you the idea regarding the slope, that is double derivative d2y by dx square. Double differentiation gives you the idea for concavity, and that could be integration of y dx. That can give you the idea within limits xi to xf. That will give you the idea regarding the area under the curve. Okay. So the phase 1 of our discussion is, which we are handling today, that is use of calculus in graph. Phase 2, which we will take in this bridge course, but not today, later on some fine day, we will also talk about the phase 2. But once you complete these 2 phases, definitely there is no graphical problem which will be bothering you. So phase 2, which means nothing will be tough for you. Everything will be very easy. Phase 2, different shapes of graphs. Different shapes of graphs. In these different shapes of graphs, we again have 3 components. We have 3 different components. We have straight line, we have conic section. Conic sections will involve circle, parabola, ellipse, hyperbola. Circle, parabola, ellipse, hyperbola. How to judge the equation, how to draw the design, where the curve will pass from, how to comment about the slope, everything. And the third thing will be trigonometric graphs. We all know that how trigonometric functions graph, sine graph, cos graph is very important for us for 5 different chapters of physics. Simple harmonic motion, waves, EM waves, wave optics, and AC alternating current. So 2 are the units from 11th class, 3 are the units from 12th class. Overall in NEET syllabus, in these 5 chapters, there is a lot of importance of trigonometric graphs. the shape, the periodicity, the points of zero crossing, the range, everything. Okay, so the way we are going to deal with the phase 1 today, that is involvement of calculus, how to judge the differentiation, double differentiation and slope, or what is the contribution of differentiation, double differentiation and slope in case of the graphical analysis. So that is the phase 1, that is our today's discussion. Phase 2, the shape of different types of graphs from their equation, that we are going to discuss later. Okay, this we are going to discuss later on some other day. I hope the psychology behind the graphical problems is clear to you. Now I would definitely suggest you to take a screenshot. All right, I hope that's fine for you. Now, our way, yeah. Students, we will talk about the problems also, in which we talk about the common way of doing the problems, and we will also talk about the our way of doing the problems. But let us develop the fundamentals for a while. First of all, let us learn, let us understand. And with this topic also, I'll keep going slow, because I know that majority of us feel some sort of discomfort with the graphical problem. And if we know, in your language, in the language of medical aspirants or in the language of doctors, what we say, diagnosis is very much important. And once the diagnosis is done, half of the treatment is automatically done. Which means if today we are able to find out, if today we are able to ask ourselves, what is the problem, man? What is the issue with the graph? Then definitely we'll be able to flush out our fear for the graphs. Okay, and we'll be highly comfortable and very happy looking today onwards, looking at any graphical problem. So what my point of view is, my opinion is that in order to understand any graph, what information you get from the graph, what you can read in the graph, and how you can design any graph, that will depend on the two phases. One of the phase, that is use of calculus, we are starting right now. Another phase, that the different shapes and design and periodicity and many more related things, we will talk about some other day. Okay, now use of calculus in graphs. So first of all, if there is there are three phases, as I have there are three things in the phase 1, that is differentiation, double differentiation and integration. So I'm talking about all of them: differentiation, double differentiation and integration. So first of all, I'll talk about the first derivative. First, so use of calculus in graph. Suppose I say that y as a function of x is given to you. That is, you're drawing a graph, yx, and here it is y as a function of x. Here let us suppose that y as a function of x, a graph is given to us. Okay, a random graph. So I'm not judging the shape or the quadrant of this graph as of now. So what I'm doing is, I'm talking about one by one all the parts of the calculus involved to this. So first of all, I'm talking about first derivative. If I talk about first derivative, that is dy by dx. dy by dx. What this dy by dx is, that will give us? dy by dx will give us slope m, or tan theta, where theta is the angle made with the positive direction of x-axis, in the anti-clockwise sense. Okay, so the first derivative dy by dx gives you slope. For talking much about the slope, I would like to give you the representations of the straight line. Suppose my straight line is this. So can you see that it is an increasing straight line? For this increasing straight line, the slope is always taken as positive. This slope is always taken as positive. Why, sir? Because if I try to make an angle theta with the x-axis, that theta will be acute angle, first quadrant. So for first quadrant, tan is positive. That's why the slope is coming out to be positive. Similarly, I will say that if this is the slope, this slope, decreasing line you can see. So here the slope is negative. Why it is negative, sir? Because if I try to here to take the angle with the positive direction of x-axis in the anti-clockwise sense, this angle is acute. Tan of acute angles means first quadrant, it should be positive. Here, if I try to draw the positive direction of x-axis and then I try to draw the angle in the anti-clockwise sense, positive direction of x-axis, anti-clockwise sense, this angle is obtuse. See, everyone says that, this slope is positive, this slope is negative. No one talks about why this slope is positive and why this slope is negative. That's where I'm emphasizing on. That's where our basic logic and knowledge lies. See, a positive direction of x-axis, anti-clockwise sense, the angle is acute. Acute means first quadrant. All trigonometric functions for the acute angles are positive. Similarly, if it's a decreasing line, positive direction of x-axis, anti-clockwise sense, you will get an obtuse angle. If you're getting an obtuse angle here, definitely in the second quadrant, only sine is positive. Tan and cos and cot and secant, these are negative for the obtuse angles here, second quadrant here, I would say. So here it is negative. Now, if I talk about a horizontal line like this, you can see what is the angle it is making with the x-axis? 0. So tan 0 is also 0. And here, now onwards, you can remember that m is equal to 0. Here, theta is also, theta x, angle with the x-axis is also 0. And the fourth is the vertical line. Fourth is the vertical line. If I draw a vertical line here, if I'm drawing a vertical line here, what we can see is that here theta is 90 degrees. Positive direction of x-axis, anti-clockwise sense, theta x is equal to 90 degrees. Tan 90 is not defined. So that's why you say that slope for a vertical line is not defined. Have we understood something? What did we understand right now? We have seen that in order to understand any graph, the use of calculus is required. Use of calculus means we have to talk about three things: involvement of or use of first derivative, importance of the second derivative, and use or importance of the integration. So first derivative gives you slope. Any chapter, any topic, any graph, first derivative will give you slope. Slope means there can be 4 different types of slopes available: increasing line, positive slope; decreasing, negative; horizontal line, zero slope; vertical line, not defined slope. Why it will be positive, negative, zero and not defined? That basic logic also I have delivered, I have told you. So even in the exam or any problem in your practice, when you get stuck, don't worry, close your eyes, breathe in, breathe out, recall the basic logic in a minute, and then always take the restart. See, we all have to be a very strong believer of taking the restart in our preparation also, as well as in life also. Failures will come here. Whenever you prepare for something, whenever you try something, you keep on going, you give your level best. Then also, winning and losing, both are the parts of the same game. Similarly, if you target to achieve something, you may achieve that. That will be a win-win situation for you also, for us also, for your parents also. But we must embrace the parts of our life when we get the failures also. Because then that's the point we are learning. That's the point of life where we are learning, and there is a chance of improving ourselves and then again taking the restart. Okay, so whenever we are dealing with the graphical problems in today's session also, you may feel that there are a lot of things coming in your head. It's totally fine. Just stay calm, recall, and again take the restart. So the first derivative gives you the entire idea regarding the slope. All right, I hope we are clear with this. Let me take another copy here so that I can talk about the second thing, that is concavity. And don't worry, it's here only. If you want, you can take the screenshot. All right. Now, if I talk about the second one is basically second derivative. Second part is second derivative. Second derivative, that is d2y by dx square. d2y by dx square. This d2y by dx square gives you concavity. Concavity. All right. Now, what is the meaning of concavity, sir? You can see here, this shape is concave upwards. This shape is concave downwards. And any straight line, if you yourself are saying that you are dealing with straight line means there is no bending, there is no concavity. Any straight line, the concavity is 0. Concavity, which is d2y by dx square, that is basically equal to 0. So for any straight line, our concavity will be 0. For straight line, we generally deal with the slope and we are happy while dealing with the slope, and concavity will be 0. Here, for any bending, what kind of bending it is, concave upward or concave downwards, these are the two shapes which we are going to deal. Now, if you see here, this concave upwards is given by positive double derivative. d2y by dx square is positive. So if double derivative is 0, it might represent a straight line, right? If double derivative is positive, it is going to represent concave upwards. And if double derivative is negative, d2y by dx square is negative, then definitely it is going to represent concave downwards. Here, this is basically concave upwards, and here it is concave downwards. Interesting part is that when double derivative is positive, it is concave upwards, you will get a minima. Somewhere. And when the double derivative is negative, you are dealing with a concave downward graph, you will get a maxima. And where we are going to deal with the concept of concavity, sir? It might be new for you. Slope, everyone is familiar with. But where the concavity will come into the picture? Concavity will majorly come into the picture. It will be majorly used in kinematics, right? Where in kinematics it is majorly used. Otherwise, it is used in many other topics and chapters also. So, majorly used in xt graph, xt curve to comment about acceleration. Acceleration. Now, why is that so, sir? Because we know that from position, if you take the single derivative, then you will get the velocity. If you differentiate the velocity again, you will get the acceleration. So in position time graph, if you take single derivative or slope, you will get the velocity. But if you take the double derivative, you will get the acceleration. Okay, single derivative, slope, double derivative, concavity. So in xt graph, slope will give you velocity and concavity will give you acceleration. Is that fine? Now, the last part here is integration. Integration gives you area. That is, I will say, if I am writing integration of y dx within limits xi to xf, and similarly, if I write integration of x dy within limits yi to yf. So if you are integrating with respect to x, integration of y dx, or you can also write it as integration of fx, because y was a function of x, no? Fx dx within limits xi to xf. Going a bit mathematical, no? Going a bit mathematical? Is it a bit boring? No, it's not boring, it's interesting. Yeah, it is going mathematical because that's where we lag. If we try to understand and improve our mathematical skills, which I am talking about here, definitely all type of graphs are going to be very easy for us. So keep looking and keep listening. I'll keep repeating my words. I'll keep repeating the same things till the time the same things are not stored in your head. Okay. So integration, that is integration of y dx or fx dx. That will give you what? That gives you area under, that will give you area under y is equal to fx curve. Keep listening, huh? Area under y is equal to fx curve. This y is equal to fx curve. It's area, but that can even enclose an area with x-axis, or it can even enclose the area with y-axis. If you are integrating it with respect to x-axis, then area will be enclosed with x, and the limits will also be applied on the x-axis. Means area under y is equal to fx curve with x-axis within limits xi to xf. Within limits xi to xf. This is the situation. So what I can say here is, this is the area under the curve. Similarly, if I try to write it as integration of x dy, so now I am integrating with respect to y. So area will be enclosed with y-axis. Here I was integrating with respect to x. So area was enclosed with x-axis. And the limits are also from xi to xf. I'll show you a graph, then we'll compare both. And if I try to write this as integration x dy, now I'm integrating with respect to y-axis. If I'm integrating with respect to y-axis, the area must be enclosed with y-axis within limits. So that will be area under xy curve with y-axis within limits yi to yf. Let me show you diagrammatically. So I'm going to take one graph here. This is y-axis, x-axis, origin, and this is y as a function of x. Okay, and here y-axis, x-axis, origin. Now whenever you represent a curve or an equation, you can even represent y as a function of x, or you can express x as a function of y. Just like a linear equation in two variables, you can either express x in terms of y, or you can represent y in terms of x. So here also you can represent y in terms of x, or you can represent x in terms of y. Okay, now the moment you want to talk about integration of x dy, then area must be taken with y-axis within limits y initial to y final. So you will say, suppose this is my y initial, this is my y final, integration will give me this area. Remember, first derivative gives you slope. First derivative is giving you slope. Second derivative is giving you concavity. It is also used, the second derivative is majorly used in the kinematics graph of xt, where you want to comment about A in kinematics, but at many other places, right? Also, that is a very useful trick to deal with the maxima and minima technique in physics. You know, many times examiner says determine the maximum value or the minimum value. So concavity gives you the foundation for dealing with the maxima and minima. Also, for any physical quantity to be maximum and minimum, its first derivative should be 0, and second derivative, if second derivative is positive, you will get a minima. If second derivative is negative, you are dealing with concave downwards, you will get a maxima. Similarly, the third part of the calculus, that is integration, that integration gives you the area. And area with which axis, sir? That depends on with which variable you are integrating it. With respect to what variable you are integrating it. So integration of x dy means you are integrating with respect to y. So the limits will also be of y-axis and the area must be enclosed with y-axis. Similarly, when you were dealing with here, so you are integrating it with respect to x-axis. If you are integrating with respect to x-axis, the area must also be enclosed with the x-axis and the limits must also be applied on x-axis, x initial to x final, and diagrammatically you are dealing with this area. I hope we are clear with this. So there are a lot of things written on board, but I have already revised it for you. Look at the board, take the screenshot, do let me know that if there is any doubt, you can just post your doubt in the comment section. I'll definitely take your doubt. Positive concavity, we will get a minima. Negative concavity, we will get a maxima. Any doubts? Any doubts to anyone? Is that clear? If that's clear, please take a screenshot, because now we are going to start one by one with all the graphs of kinematics. We have understood the type of graph and the fundamentals required in phase 1 to deal and study any type of graph. Now we will take up one by one all different types of kinematics graph along with the examples. Then we will see some problems also. Crystal clear? Very nice, very nice. Let's move ahead. So first of all is position time graph. Position time graph. So the graph will look like this only. That, sir, position can be positive or negative. Anything. Position can be positive or negative. Anything. And time must be taken into the positive direction. So I'm not stretching it along the negative direction, right? Time makes sense when we are dealing with positive time instants here, okay, for our discussion. Now, similar will be, before I talk about different things here, I want you to understand similar can be displacement time graph. Same being a vector quantity, it can be positive, negative, zero, anything. Displacement time graph can also be same. But for distance time graph, we need to make few pointers in our head. But for distance time graph, what we can say is, remember three things. First of all, for a moving body, distance can never be zero. Displacement can be zero. A body can move ahead and come back the shortest distance between initial and final point. If the initial and final point are same, then shortest distance between them is zero. Naturally, everyone knows. So what we need to understand here is, but for distance time graph, for a moving body, first thing you need to understand is distance can never be zero. So while drawing the graph, just take care of these 3 points. First point is, for a moving body, distance can never be zero, although displacement could be, okay, if initial and final points are coinciding. Second thing is, distance can never be negative. So if you're drawing the distance time graph, this portion is not allowed here. Distance can never be negative. And distance can never decrease, means position or displacement can increase and then decrease also. But distance still here can increase, and after that you can draw it like this, but it can never decrease. It can never decrease. At right time we will deal with such problems, but you need to remember the third point. Distance can, actual path length can never decrease. If the body stops, the actual path length will also be fixed. But if the body is moving, the actual path length with time will keep on definitely increasing. Is that fine? All right. So position time graph we are trying to talk here. Similar can be the displacement time graph, but for the distance time graph, you must remember these 3 points. This is the zone where the students, where the aspirants do some mistake. So let me take one by one all 3 things here. So the first thing for us is, that is the derivative, first derivative, dy by dx, or here, let me write it like this. Slope will give you what? Slope, if you are having a graph or if you want to draw the graph, the slope gives you the first derivative. Slope will give you the first derivative. First derivative is dy by dx here. So basically that is dx by dt. Dx by dt, that is velocity. Okay. V. Second thing, What second derivative will give you? Concavity. So concavity is given by double derivative d2x by dt square, or you can write it as dv by dt. When you have the first derivative, you will differentiate it again. Definitely you will get the second derivative. That's what the meaning is, right? So that will give you what? That will give you acceleration. Acceleration A. All right. And similarly, if you have to talk about the third thing, that third thing is integration or area. Area will be given by mathematically integration of x dt, x dt, x dt. So the limits will also be taken for t axis, ti to tf. So this thing is going to be useless for NEET. This is going to be useless for NEET. See, I will avoid saying that whether it gives you a physical quantity in the entire physics or not. Obviously, for the NEET exam, you don't have to do a PhD in entire physics, or you don't have to deal with every physical quantity available in the nature, right? You don't have to, naturally. So basically, we will only emphasize on that this is a certain, like out of the 6 graphs, the first one is in front of you. Its variants, what you need to do and what you don't need to do are in front of you. And all the 3 contributions of calculus, first derivative, second derivative, and integration, means slope, concavity, and area, what they will give you and whether it is useful for our NEET 2026 preparation or not, that I'm trying to tell. I hope that's clear to us. Quickly take a screenshot. This is the first graph out of the 6. All right, let me give you one example for that. We are talking about one example. So example number 1, in which they are telling us that suppose this is, suppose here we are dealing with position time graph, xt graph, okay? And there are 2 bodies given to us, body A and body B, and they are making certain angles here. This angle is 30 degrees and this angle here is 45 degrees, and they are asking you what is VA by VB. What is VA by VB? That's the question, suppose. That is the problem. So how to deal with it? You can simply say here VA by VB. So you are dealing with, examiner wants you to deal with the velocity. Examiner wants you to deal with the velocity giving the position time graph. So what we need to know that in xt graph, velocity is given by dx by dt. That is, velocity is given by slope m or tan theta. That's what we have learned, slope m or tan theta. So can I say the VA by VB value will be equal to tan theta A by tan theta B? Just remember that these are the angles must be taken. Angles must be taken with t-axis. Angles must be taken. So when I was teaching you the y-x in Cartesian plane, I told the angle must be taken with x-axis. But if you want to write dx by dt, then angle must be taken with t-axis. Angle must be made with t-axis. Whichever parameter comes in the denominator, angle is made with that axis. What I just said, repeat with me. Whichever parameter, whichever physical quantity will come in the denominator, angle will be made with that axis. So angle must be taken with t-axis. T-axis. All right. So that will be equal to, yes, I can see many of you are answering me and you are answering right only, but I would like to still emphasize on this point here. All right, that the angles must be made with t-axis. Okay, so tan theta A. So see here, the things are very simple, that the angles are directly made with t-axis. So for A, it is tan 30 degrees, and for B with t-axis, it is tan 45 degrees. We all know tan 30 is 1 by root 3 and tan 45 degrees is 1, and hence the final answer is 1 by root 3. It's the ratio of same type of physical quantity, velocity by velocity, so it has to be unitless as well as dimensionless. But now suppose I modify this problem for you and I say that this is time versus position graph time versus position graph. This is A and this is B. This angle here is 37 degrees. 37 degrees. And this angle here is 60 degrees. All right. That's the question. Question is again the same, that tell me the value of VA by VB. So maximum students know that problem. Examiner would be asking you this problem, and doing this directly theta A by theta B here will be definitely a common mistake. Examiner knows that what majority of students are going to do as a mistake. So that is sometimes option A as available option in the out of the 4. Okay. So just telling you, just making you aware that what not to do. Just remember, you don't have to every time take the angle with the x-axis. In any graph, in any chapter and topic, angle must be taken with the axis which contains the physical quantity of the denominator. All right. So here, if I talk about, so I will write VA by VB must be equal to tan theta A by tan theta B. Okay, tan theta A by tan theta B, but the angles must be made with t-axis, all right. So with t-axis, this is the t-axis this time. The A, this angle is 37 degrees. So what will be this angle here? This angle will be 53 degrees. And what will be this angle here? This angle here will be 30 degrees, 30 degrees. So tan theta A will be tan 53 degrees. And tan theta B will be tan 30 degrees. So what you are going to have here is tan 53 degrees is 4 by 3 and tan 30 degrees is 1 by root 3. Hence that will be equal to 4 by 3 into root 3. Denominator will become numerator, or you can also call it as 4 by root 3. Okay. Generally, we avoid writing the root inside the denominator. That's why I would say the first one is a more appropriate version. That's fine. That's fine. Is that all right? Now let me look in the comment section. Yeah. Channa Sri, very nice. Correct answer. Prashant, previous question, previous part, absolutely correct here. I hope you people are understanding, right? Basic details I'm telling you in between. Okay, so this was the first graph. This is the first illustration that, that is dealing with both the graphs, both ways, xt as well as tx. All right, chaliye. You can take the screenshot. We are moving ahead. Yes. Now, let me give you another graph, then we will talk about the remaining examples. Suppose we talk about the velocity time graph. Suppose we are talking, or let us talk about this only, velocity time graph. In velocity time graph, what do we have? Velocity can be positive, negative, anything. Okay. Velocity time graph. V as a function of t we have. While drawing the speed time graph, for speed time graph, we will simply understand, remember, speed can't be negative. Speed can't be negative. So this implies positive part will be same. This is the tip from my side. Positive part will be same. Number one. And take the mirror image. Take the mirror image of negative part. Take the mirror image of negative part about t-axis. Take the mirror image of negative part of velocity time graph about the t-axis. Now, how and why it is happening? Let us try to see that also. I'm just shifting it here. All right. So, now see, this is the tip. Now see, I'll give you one example when like we will directly take up the problem and a good level problem. So basically here, first of all, if I talk about what the slope will give me, so slope m is equal to tan theta, that will give you dy by dx, here dv by dt, that is acceleration, all right, A. Similarly, if I talk about the double derivative, concavity, double derivative is concavity here. So concavity will give me double derivative d2v by dt square, or you can write it as dA by dt, time rate of change of acceleration, that is jerk, that's rare for NEET. I will not say useless for NEET, I will say rare for NEET, it's rare, okay, but can come, it's important. And similarly, if I talk about the area, so area will give you integration of v dt within limits ti to tf. Now that can give you two different types of area, okay. That area could be the total area, upper area is also taken as positive and the lower area is also taken as positive, then total area gives you distance. And if you take the net area, net algebraic area, net area means positive and negative. So above the t-axis you will consider it to be positive, below the t-axis you will consider it to be negative. So that will give you displacement. All right, total area will give you a distance, net area will give you a displacement. Let me take an example for this. For example, suppose I say that this is my VT curve, velocity time curve, and it is like this, A1, A2. So if we are taking the total area, so that will be equal to A1 plus A2. Above the t-axis, below the t-axis, if I just directly add both the areas, it will give you distance total. And if I want to take the net area, then upper area will be positive and lower area will be negative. So that is A1 minus A2. Is that clear? All right. So just remember that here we are dealing with the velocity time graph, but what if the examiner is asking you the speed time graph? So the only parameter, the way I have told you here, that in position time you can easily deal, but for drawing the distance time graph you need to remember the three things. Similarly, from velocity time, if you want to draw the speed time graph, then you have to remember only one thing, that speed can never be negative. So you just need to take the mirror image of that. All right, you can take the screenshot, then we'll move ahead. All right. Now let me give you one problem here. In this problem, suppose we are talking about this. A ball is thrown vertically upwards. Which of the following graphs represent velocity time graph of the ball during its flight? Air resistance is neglected. So they are asking you which of the following graph represent velocity time graph of the ball during its flight. A ball is thrown vertically upwards. So the situation is that there is a ball. It is thrown vertically upwards with some initial velocity that is naturally positive. And all upward things are taken to be positive and downwards are taken to be negative. It will go and somewhere here at h max, its velocity will be zero. And then in its downward journey, the velocity must be negatively increasing. In its upward journey, it was positive and decreasing. These two arrows are representing, let me change the color for it. So I'm trying to tell you that these are decreasing in magnitude, and here this is increasing in magnitude. So velocity must be, first of all, velocity in positive decreasing, then in negative increasing, positive decreasing, negative increasing, positive decreasing, negative increasing. You see, positively it decreases, then negatively increases. This is the correct curve. Few more points here. First of all, this is the fourth graph, is the correct graph. but it is not necessary while bubbling the OMR. Just keep my words in mind. It is not necessary that the fourth graph will also be the fourth option. See, for the simplicity, I have taken it here, but we must talk about it. That fourth graph is the correct graph, which I have shown you here. There are multiple ways. This is one way, logical way of understanding that. Okay. So this is one of the graphs. The fourth graph is correct, but that is not necessarily to be the fourth option. Here it is coincidentally the fourth option. Okay. So correct graph is option 4. Correct graph is 4. The correct option is option D. Right? Then you should be bubbling the D. So this is way 1 of dealing with it. Way 1 of talking about it. Logic number 2, way 2 of talking about it is, I will simply say that acceleration, motion under gravity, if air drag is ignored, let me write this second one here. Way 2 I am writing here. If air drag is ignored, way 2, if air drag is ignored, can I say here acceleration? Acceleration will be acceleration is equal to minus g, constant. And in VT graph, all the 4 options are in VT graph. In VT graph, acceleration is given by slope. So dv by dt or slope is basically a negative constant. dv by dt or slope is going to be a negative constant. Just need to focus on this graph, this logic. See that choose the graph, you have to choose that graph dear in which the slope is negative constant. So here the slope is, if I try to mention that here, so I will say for the first portion slope is negative, second portion slope is positive. Here the slope is positive and here the slope is negative. Here the slope is throughout negative constant, because for straight line slope is constant. Here you will say slope is negative and here you will say slope is positive. So one logic is you can try to feel the motion and then stick with the convention. Upward vectors are positive, downward vectors are negative. Way 2 is that in VT graph you can also comment about the slope. But way 3, our way, we want to just see these type of questions. We want to just see and orally answer. Way 3 is option elimination. Option elimination. Logic of option elimination is at the same time there can't be multiple values of x, v, a. At the same time there can't be multiple values of x, v, a. For example, if you are drawing VT graph, and the graph is, suppose this, the graph is this or the graph is this, then these two graphs can be directly, just look at it and eliminate it. The reason is, if you try to talk about any time instant, at some time t0, you will get two values of velocity, here also and here also, which is not possible, no. At the same time, the particle can possess only unique position, only unique velocity, only unique acceleration. There cannot be multiple positions of the particle. Only ghost and God are omnipresent. Means I would say that they can be present everywhere. They can be present at multiple positions at the same time. But otherwise, okay, jokes apart, in any physically realizable situation, multiple values of x, v and a are not possible. So you will say here it's t0 time and there are multiple values of velocity, which is again not possible. These graphs are not possible curves. Okay. And if I talk about option A, then option A is a correct speed time graph. Option A is correct speed time graph. It's not a correct velocity time graph. All right. Velocity time graph is option D. Correct speed time graph, if they are asking, then I would have selected. That's what I've taught you now, that if you want to draw speed time with velocity time, then positive part can be taken as it is. But for the negative part, you can take its mirror image. So that's a correct speed time graph. speed time curve. Okay. Now you can take the screenshot. We have really talked a lot, multiple methods, R way, general way, logical way. What are the parameters? What are the things you need to keep it in mind? Take the screenshot, then I'll take you towards another one. All right. Now let me take you towards a JEE based problem. Yeah, a very nice problem. See, that's a previous year IIT JEE screening problem. You know, there used to be two different rounds, screening round and mains round and JEE previously. But anyways, this problem can definitely come in NEET for 2026 exam also, as per the standards what we have seen in 2025. A ball is dropped vertically from a height d above the ground. You are just dropping a ball, okay? It hits the ground, it bounces up vertically to a height d by 2. Means it has lost some energy, maybe due to air friction, and no, you need to neglect subsequent motion and air resistance. You have to ignore air resistance. So obviously during the impact, the collision was not elastic. The ball has lost some energy. That's why it is coming from a greater height, but going up to a lesser height. Its velocity v varies with the height above the ground is. You have to choose VH graph and its velocity. Its velocity. Velocity means direction plus minus must be considered. In speed graph, you have to always take it as positive. So here direction must be considered. All right. So how to consider the direction here? So we will see that in this VH curve, you have to see. So I will talk about the equations naturally. So I will be saying that how to relate. You can relate it as like if acceleration is equal to minus g is constant. If acceleration is equal to minus g is constant, then V and T are linearly related. V and T are linearly. I can express that in mathematical equations. Common way of doing this problem is using the mathematical equations, understanding the equation, then drawing the graph. Do we want to do? Like, do we really like that much of maths? No, we don't like to do it. We can do, but we don't want to do. What we can do is we will just try to relate some basic logics here. So VT curve are linearly related. For example, that is V equals to U plus AT. V equals to U plus AT. So there is a linear relationship between velocity and time. But Vs are non-linearly related. Non-linearly related means that is V square, third equation of motion. If I try to apply, V square is equal to U square plus 2as. So see, what is the power of S? 1. But what is the power of V? 2. So obviously they are quadratically related, non-linearly related. All right. So what I'm trying to say that VT curve are linearly related. So linearly related means the graph could be a straight line. The graph would be a straight line. Obviously, always must be a straight line. And non-linearly related must not be a straight line. Must not be a straight line. It can be a parabola or any random curve, but it must not be a straight line. For the quadratic, it must be a parabola. But I'm just talking about the linearity, whether linear relationship is satisfied or not. So here, if you see that you have to draw the velocity time, means you have to draw the velocity versus h, VH. So definitely it's a non-linear one. Non-linear one. So you have to consider a non-linear one, and you have to consider positive as well as negative, because while going up it is positive, while coming down it is negative. Okay, so choose that graph in which plus and minus both portions are available, but it is not a straight line. I repeat, everyone in the option, choose everyone in the out of the options, tell me in the comment section, you have to choose that graph which is not a linear graph and contains positive and negative portion both. Which is not a linear graph and contains positive and negative portion both. You see, positive, negative portion, positive, negative here. Here totally positive, here totally negative. So positive, negative, you got here, and it's not a straight line. The correct option is option A. The correct option is option A. The second, what about the remaining, sir? It is not possible. For me, I would say that here this VH curve, here this VH curve, instead of VH, it could be correct VT curve. Correct VT. This option I am talking about, option C, it could be correct VT curve for us, because velocity versus time, positive, negative, and that could have been a linearly related graph. And similarly, B option is correct speed versus h graph, speed versus height. So what problem we are doing today, that is obviously important, but that is also important that if the examiner is asking you the similar but not the same problem. Here we are dealing with VH, velocity versus height. What if examiner is asking you speed versus height? Then this would be the correct option. What if examiner is asking you the speed versus velocity versus time? Then this would be the correct option. What about speed versus time, sir? So correct speed versus time, positive will remain positive, negative can be taken as positive. All right, because speed can never be negative. I hope everything is clear to you. All right. Not ABCD, dear, not Mohit, not ABCD. I'm telling you different situation. For different questions asked by the examiner, we can answer it differently. Quickly take the screenshot, guys. All right. Chalo. Let's talk about another graph now. Let's talk about acceleration time graph. Acceleration time graph. In acceleration time graph, again, quickly I'll show you this. In acceleration time graph, acceleration being vector can be positive, negative, zero, anything. If I talk about the first thing, that is slope. So slope will give you, that is dA by dt, that will give you jerk. Very rare for NEET. And after that, subsequent differentiations are defined. I should not say that it is the end of the story. Subsequent differentiation, dA by dt, d2a by dt, you can further keep on differentiating the position or velocity or acceleration for much higher degrees with time. So those are also defined physical quantities, but those are not at all relevant for our NEET syllabus. So I'll just stop there only. So concavity, that is d2a by dt square, that is, I will say, useless for NEET. This we don't have to entertain. All right. And if I talk about the integration or area, that is, I'll say integration of a dt, t initial to t final. So that will give you change in velocity, delta v vector, which is v vector minus u vector. That is change in velocity vector. Okay. Where else we can use this, sir? What are the other places where we can use this? So I will say that here, this change in velocity vector can also be used during the discussion of impulse, which is j vector, that is defined as change in momentum vector. You know, that will come in Newton's laws of motion also. Change in momentum vector can be written as delta of mv vector, where mass is always constant, so that is m delta v vector. That is, you can directly conclude here that impulse j vector is defined as product of mass into area under AT curve. All right. So this is another place where we are going to make use of this area under curve for AT graph. All right. Very simple. Quickly take the screenshot so that we can talk about 1-2 more situations. I hope that's fine. Chaliye, let's move on to the next one. Velocity position graph. Now these are the rare graph, position time, velocity time, acceleration time, everyone is comfortable with. We have seen that also. Now we will talk about velocity versus position graph. Okay, so in velocity position graph, what you need to see is again, okay, so I'll draw it here also because position can also be positive, negative, velocity can also be positive and negative. So first of all, if I talk about the slope, so slope, that is dv by dx. Slope is dv by dx, dy by dx. So here on the y-axis you are drawing velocity, we are plotting velocity, so it is dv by dx. So if you are trying to understand where it is used, we know that instantaneous acceleration will be equal to instantaneous velocity into dv by dx, instantaneous slope, v dv by dx. That is, we can write here that instantaneous acceleration is given by the product of instantaneous velocity to the slope of vx curve. So that's where we are going to use, we are directly going to use the slope in case of vx, position versus x. Concavity, velocity versus position, that is concavity. If we talk about, that is, it is that is d2v by dx square. That is going to be useless for NEET. Generally it's not useful here, generally it's not used. And if we talk about the last one, that is, if we talk about the last one, that is the area, that is integration of v dx within limits xi to xf, vs curve, right? That is also useless for NEET. We are not going to use it directly when it comes. But sir, if we are not going to use it directly, why we are writing these expressions? Because if the examiner deliberately wants you to use that, then you don't have any other choice. What type of such problems will be there in later days of our journey? And in fact, when you will come here, when we'll be having core practice sessions, higher level question practice session, then definitely we are going to deal with such problems. All right, for as of now, you are supposed to remember all this. Is that clear? You can quickly take a screenshot. Then I'll take you towards another interesting problem for the day. Yes, in different topics and chapters it is used. Right now here it is not used directly. Chaliye. So let us talk about an important problem for NEET 2026. The problem is, examiner is giving you the Vx curve, velocity versus position curve, and the graph is this, V0, X0. This is the graph. And the question is, draw AX graph. Draw AX curve. This is the problem. Vx curve is given to you and Ax curve is required. Vx curve is given to you and Ax curve is required. How to draw that? Way 1, common way. Way 1, that is the common way how people do it. Common way of doing that. I will express this velocity, since it's a straight line, you can express in terms of y equals to mx plus c. That means here y-axis parameter is nothing but the velocity. The slope for a decreasing line, slope is positive or negative? Slope is definitely negative. Minus perpendicular by base. Tan theta is perpendicular by base, that is v0 by x0 into x plus c. C is the y-intercept. Here the c value, y-intercept is v0 over here. So this is what you have got when you try to express the velocity versus x, velocity in terms of x. Now the target is we need to draw the Ax curve. So how do we get that? We know that A is given by v dv by dx, v dv by dx. So the value of v is directly here. The value of v is what you have expressed here, that is minus of v0 by x0 into x plus v0, and dv by dx is nothing but the slope. This term is nothing but the slope Slope you have already seen that is minus of v naught by x naught. Okay, this implies the acceleration value here will be, if you multiply it, it will be minus minus plus v naught by x naught whole square into x plus minus minus v naught square by x naught. So if you again try to compare it with y equals to mx plus c, if you try to compare it with y equals to mx plus c, see what you will realize. You will realize that slope is positive. Slope is positive over here and y-intercept is negative. If slope is positive and y-intercept is negative, this implies the correct graph is, it's ax curve. Ultimately, it is going to be a straight line having negative y-intercept and positive slope. Negative y-intercept and positive slope. This is the way generally this problem is supposed to, you are supposed to deal with this problem. But we are happy once we are doing it our way. Now, what is our way of doing it? We will say, see, ultimately A is equal to V dV by dx it is. If I understand what is happening with time or what is happening in the journey with the value of V and what is happening with dV by dx, combinedly we can comment about their behavior. For example, if I talk about the value of V, so it is positive throughout the journey and it is decreasing. So it is positive and decreasing. And if I comment about the value of dV by dx, that is the slope, that is a negative constant. Slope is negative here, right? M is negative and it's a constant. So definitely the slope is negative constant. So now if I talk about the combined behavior, then definitely we will say about the acceleration. If you multiply positive and negative, you will get negative. And if you multiply a physical quantity which is decreasing to another physical quantity which is constant. So if you are multiplying a decreasing behavior and constant behavior, then definitely it is also decreasing. So acceleration must be plotted in negative and its negative magnitude should be decreasing with time. Acceleration, see, same here. Acceleration must be plotted in negative and its negative magnitude must be reducing with time. Isn't that interesting? So I would suggest you to take the screenshot. So complete notes are also to be attached in the description today evening or maybe tomorrow. Okay, so you can check for it. I hope you have enjoyed the session and a lot of graphs we have completed today. Make sure before you sleep tonight, you just take a casual recap, because as I'm saying since the starting of the session that whatever fundamentals we are learning these days, these we are emphasizing for the kinematics unit, but these are not only limited to here, they are also applicable in almost every topic and chapter of physics. All right, so here we stop for today. We'll soon meet tomorrow with some new interesting fundamentals and topics. So you can take a short break and then your chemistry lecture will be started with Anirudh sir. Okay, all the best. Bye bye.